Hello, class, and welcome to the next lesson in Eureka Math for 8th grade. We are in Module 4, and we're going to start Lesson 7 today. Lesson 7 is called Classification of Solutions, and it's on pages 61 through 69 of your workbooks. So grab those pages, grab some pages for some notes, grab your writing tools, and let's begin. And like always, we're going to start with vocabulary. We have a list of vocabulary words that we're going to study when we talk about classification of solutions. So some of these words we've seen before. Some of these are brand new. So please copy down the words and their definitions. And like always in these video lessons, if I'm going too fast, please pause the video, finish writing, and catch up. And then resume the video when you are ready. But here's the vocabulary. The first word we're going to see is coefficients. A coefficient is a number that multiplies a variable. So, like in the term 3x, the x is the variable. 3 is called a coefficient because it multiplies x. So that's the coefficient. 3 is the coefficient. So any number you multiply a variable by is a coefficient. Next word is a constant. A constant is an amount in an equation that does not change. An amount that does not change. So in other words, not a variable. It is a term that does not change, like 17. 17 has no variable connected with it, so 17 is always 17. It is always the same. It is constant. Our third vocabulary word we've seen before as well is no solution. No solution describes when there is no value for a variable that will make an equation true. There is nothing we can replace x with that will make the equation true. When x can be nothing, that means no solution. So no solution means nothing will work for x. It means nothing will work for x. There is no solution. There is no answer for x. Two more vocabulary words, so let me scroll up. We have unique solution and infinite solutions. They're kind of connected to no solution. They just mean different things. So some equations have no solution where there is no answer. Some equations have a unique solution when there is only one value for x that will make an equation true. When only one value for a variable makes an equation true, we call that a unique solution. X or whatever variable can only be one thing, a unique number, a special number. So when x cannot equal anything, that's no solution. When x only equals one thing, that's a unique solution. And the third type of solution, when anything can equal x, when x can equal absolutely any number, we call that infinite solutions. An infinite solution is when every value for a variable makes the equation true. Whatever you say x is, the equation will always be true no matter what. So no solution, nothing can make the equation true. Unique solution, only one value can make the equation true. Infinite solution, every value makes the equation true. So those are the 5 vocabulary words: coefficients, constant, no solution, unique solution, and infinite solutions. We're going to use those ideas today, and remember we're talking about classification of solutions. So what we're going to do today, we are going to learn how to identify equations as having no solution, unique solution, or infinite solutions just by looking at them. So we're going to classify, we're going to sort equations. So we're going to look at a bunch of equations and we're going to find out which equations are no solution, which equations are unique solutions, which equations are infinite solutions. And you can do this just by looking at them. There are some tricks that will help you just know how many solutions there are by looking at them. So that's what we're finding out today. We're going to be looking at equations, and we're going to be finding out how many solutions those equations have. Now today we do not have to find the solutions. We're just finding how many solutions there are. So in other lessons in this module, we've been finding solutions. We're not necessarily doing that today. Today we're just finding how many solutions, not what they are. Let's do some examples to study this. The examples are going to be on page 61 of your page. So the examples are on page 61. So that's the end of our notes before the examples. Next thing we're going to work on is a couple examples. What I'd like you to do right now is maybe pause the video, go back, rewatch anything that you missed, rewatch anything confusing, fill in any notes that are empty that we went too fast on, and then resume the video right at this point when you're ready to look at some examples. And like I said, the examples are on page 61, so let's go there now. Page 61 looks like this, and you can see that I've already solved these examples. There you go. There are 3 examples on this page. Exercise 1, exercise 2, and exercise 3. Now, I solved these for you. So, I used the properties that we learned in the earlier part of Module 4. We started with the equation. I used the subtraction property of equality to take 5x away from both sides. And so I get 2x minus 3 equals 5. Addition property of equality, add 3 to both sides, I get 2x equals 8. Division property of equality, divide by 2, I get x equals 4. Now, x equals 4 has one solution. X can only be 4. The equation works when x is 4, but it will not work for anything else. So it only works for one value. For number 2, we had 7x minus 3 equals 7x plus 5. Now, for this, I used the subtraction property to get my x's on one side, but when I subtracted 7x from this side, I had to do minus 7x on this side, so I got negative 3 equals 5. Now, that is impossible. Negative 3 cannot never equal 5. They are 2 different values. So this means when nothing equals, when they do not equal, there is no solution. So this has no solution. So x was a specific number. That's one solution. When x goes away, we have no solution. Our third example, this one right here, 7x minus 3 equals minus 3 plus negative 3 plus 7x. When I take 7x away from this side, the variables go away, just like in example 2. But this time, I get a true statement. Negative 3 equals negative 3. Negative 3 equals negative 3. Which means this is infinite solutions. Because if x goes away, it's always true. When x goes away, it's always true. So there's infinite solutions. So this is when you solve them, this is what you get. When x equals a specific value, that's one unique solution. I put one solution. I should also add unique because that was the vocabulary word we used. Unique solution. When the x's get erased and it does not create something true, that means no solution. When the variables go away and it makes a true statement, that's infinite solutions. So that's how you can classify them after you solve them. But to do this, I had to solve number 1 to get x equals 4. I had to solve number 2 to find out the false statement. And I had to solve number 3. The trick today is how to classify solutions into unique, no, or infinite. How do I find these just by looking at the equation when I don't have to solve? Because it is possible to find these just by looking instead of solving. Let me tell you the clues you can see. to no. So let's look at the infinite. So let's start at the bottom. Infinite solutions. What do I notice about the equation I started with? This is the equation I started with. Now, if you'll notice in this, both sides are exactly the same. All they did is they changed the order. This one, they did -3. They did -3 at the end. This one, they did -3 at the beginning. All they did is they used the commutative property to put them in a different order. So both sides of the equation are actually the same. They just look different. They are the same, but look different. So we can say the clue is both expressions are the same, even if they look different. What this means is coefficients match and the constants match. There we go. That's the infinite. That's how we find infinite solutions. When the coefficients match and the constants match, that means there are infinite solutions. So those are the clues. See, look. The coefficient is 7. Coefficient is 7. Constant is -3. Constant is -3. Coefficients match. Constant match. So there are infinite solutions. When everything matches, they have infinite solutions. That is why we're looking at coefficients and constants. That's why coefficients and constants were in your vocabulary list, so that you can find them, identify them, because those are your clues. The coefficients and the constants are your clues. When the coefficients match and the constants match, we have infinite solutions. So what about no solution? What are our clues for the no solution part? Well, the equation we started with is this one. So look and see about remember our clues are going to be about the coefficients. And the constants. That's what we look at to classify solutions. So the coefficients in this example, you look at the coefficient is 7, coefficient is 7. So when there is no solution, the coefficients still match. The coefficients match. What about the constants? Well, this constant is -3. This constant is 5. So the constants do not match. And that's how you know there is no solution. So that's the difference between infinite solution and no solution. If you look, in no solution, the coefficients match, and in infinite solution, coefficients match. So when the coefficients match, it's one of these. So, and then we have to look at constants. Well, if the constants do not match, it's a no solution. But if the constants match, it is infinite solutions. So that's how we can know. That's how we can know how many solutions there are just by looking. We just look at the coefficients, we look at the constants, and that tells us if it's no solution or infinite solution. But how do we know, going back up to the top, if just by looking if there is a unique one solution? Well, this example equation looked like this. 7x minus 3 equals 5x plus 5. If you look at this, for unique solutions, the coefficients do not match. That's the clue. This coefficient is 7. This coefficient is 5. They do not match. So there is one solution. We don't even need to look at the constants for this one. If the coefficients do not match, it is one solution. So write these rules down, write these clues down, so that when we are doing our work today, you have something to look at and decide how many solutions there are. So when you're looking at an equation, if the coefficients do not match, there is one unique solution. If the coefficients match and the constants do not, there is no solution. But if everything matches, the coefficients and the constants match, there are infinite solutions. This is the page. Page 61 is the page you should have next to you because it has the rules for one unique solution, no solution, and infinite solution. This is your clue page. Make sure you have it with you during today's work. Speaking of today's work, let's go get on with some more exercises to do some work together. So you have a little bit of practice with this. Go to page 62. Looking at exercise 4, 5, 6, 7, and 8, 9, 10 on page 63. So we're going to do 7 exercises together as some practice. So the instructions say, give a brief explanation as to what kind of solution you expect the following linear equations to have. Transform the equations into simpler form if necessary. So the instructions are basically find how many solutions. Now notice it's not saying find the solution, just saying find how many solutions. Find how many. So it could be unique, no, or infinite. Those will be our choices. Unique solution, no solution, or infinite solution. And then it says we're allowed to transform the equations into simpler form if necessary, which we might want to do. So we're going to use the properties we know to simplify this. So let's look at number 4. 11x minus 2x plus 15 equals 8 plus 7 plus 9x. So the first thing I'm going to do, I'm going to simplify this so it's easier to read. I'm going to use the associative property to combine my like terms. So I'm going to combine those. I'm going to put these parentheses because those are the ones I want to do first. 11x minus 2x is 9x. 8 plus 7 is 15. Now you'll look at this and you'll say, wow, those are the same. Look, the coefficient is 9. The coefficient is 9. So coefficients match. The constant is 15. The constant is 15. Constants match. Well, back on page 61, what did we know when the coefficients match and the constants match? Right here, coefficients match, constants match, there are infinite solutions. So I don't need to solve this. I can just stop right here and say infinite solutions. And if anybody asks you why, that's your answer, but this is your explanation. Infinite solutions because the coefficients match and the constants match. This is your answer. This is your explanation. I need to see both, please. I need to see your answer and your explain. Coefficients match, constant match, therefore infinite solutions. Let's look at number 5, see what we get for number 5. Okay, for number 5, we have 3 times the quantity x minus 14 plus 1 equals negative 4x plus 5. So the first thing I'm going to do, I'm going to simplify this. I see parentheses and I see the 3 is multiplied by the parentheses, which tells me I need to use the distributive property and pass the 3 to both of them. Pass the 3 to everything inside the parentheses. So 3 times x is 3x. 3 times negative 14 is negative 42. Plus 1 equals negative 4x plus 5. Next thing I'm going to do is I'm going to combine those constants right there with the I'm going to use the associative property. I want to do that first. So I get 3x plus negative 41 equals negative 4x plus 5. Now, when we're doing this, now it's simplified. I can look at the coefficients. I can look at the constants. Well, if I just look at the coefficients first, I see coefficient 3, coefficient negative 4. So the coefficients do not match. Back on page 61, you'll notice that for infinite solutions, the coefficients have to match. For no solution, the coefficients have to match. But when the coefficients do not match, that means there is one unique solution. So the coefficients do not match, which means it follows the rules, and so there is just a one, I'll just put one unique solution because the coefficients do not match. If we keep using our properties, we can solve for x. We add 4x to this side, we add 41, we add 4x to both sides, we add 41 to both sides. We get 7x equals 46, and then we divide by 7, and we can find x. But we don't have to do that today because it's not the direct. Today we're not worrying about finding x. We're just finding that there is only one unique solution because the coefficients do not match. So we have infinite solutions where everything matched. We had a unique solution where the coefficients do not match. Let's see what's going to happen for number 6. Number 6, you can see that we have a few steps we have to do to simplify, to make it a little bit easier. So let's start by using the distributive property to pass the negative 2 on this side to everything in the parentheses. So negative 2 times 5x is negative 10x, and negative 2 times 10 is negative 20. And this side, we can keep the same right now. Well, I'm actually going to use the commutative property to move the negative 7x over here next to the x. I'm going to use the commutative property to slide it over because I can move it around. Now I'm going to use the associative property. I'm going to put the negative 3x and the negative 7x together. Negative 3x and negative 7x is negative 10x plus 32 equals negative 10x plus negative 20. It's simplified, so now I can look for my evidence. I can use my rules from page 61 to find this. So let's start by looking at the coefficients. Well, if we look at the coefficient, this coefficient is negative 10, this coefficient is negative 10. So the coefficients match. What about the constants? Well, that's 32 and that's negative 20. So the constants do not match. So how many solutions do we have? We know there's not one unique solution because a unique solution, the coefficients cannot match. This time the coefficients match. It's not infinite solutions because everything has to match, coefficients and constants. Well, the coefficients match, but the constants do not. So it has to be no solution. When the coefficients match and the constants do not, that is no solution. So match, no match means no solution. So this equation has no solution because the coefficients match, but the constants do not. You can even prove it if you keep working. If you add 10x to both sides, you get 32 equals negative 20, which is not true, no solution. But this is an extra step you don't have to do today because you know these rules. So you can just use your eyes, look at the equation, and tell me. You don't have to finish solving it today. So number 4 was infinite solutions because everything matched. 5 was one unique solution because the coefficients did not match. And 6 was no solution because the coefficients matched, but the constants did not. Let's check number 7. We have a three-way tie. Let's see what happens with number 7. Well, for number 7, the first thing I'm going to do is simplify this equation. I'm going to start by using the distributive property to multiply 1/2 by everything in the parentheses. So 1/2 times 8x is 4x, plus 1/2 times 26 is 13. And this side, I get 13 plus 4x. Well, there we go. The equation is simplified. We're ready to use our rules. Let's first look at the coefficients. The coefficient in this expression is 4. The coefficient on this side is 4. So the coefficients match for number 7. What about the constants? This expression on this side, the constant is 13. And on this side, the constant is 13. So the constants also match. Coefficients match, constants match. Therefore, using our rules on page 61, match and match means infinite solutions. So this is another equation with infinite solutions because coefficients match and constants match. So I have my answer, I have my evidence, and my proof. There we go. So we'll keep going. Hopefully this is starting to make a lot of sense. If you want to work ahead now, if you have a pretty good idea of what you're doing, you can try number 8, 9, and 10 on your own right now. Just pause the video. Work on number 8, number 9, number 10. Figure out your answer. And then when you're ready, resume the video and check your work with what I do. So right now, I would really like it if you went to page 63 and you did page 63 on your own, and then unpause the video when you're ready to check. So I'll see you in a couple minutes when you unpause the video, but right now I'm going to keep going because I don't have to pause. For number 8, 9, and 10, they're asking you to write 2 equations that have no solutions. Number 9 is 2 equations that have one unique solution. And number 10, write 2 equations that have infinite solutions. So this is where so hopefully you took your practice, the practice we did, and you came up with your own answer. So I'm just going to come up with some right now. So no solution means, if I go back to page 61, no solution means the coefficients have to match, the constants do not. So I can do something like 14x minus 5 equals 14x plus 18. That will have no solutions because the coefficients match, but the constants do not. I can even do a fraction. I could do 1/2 x equals 1/2 x plus 74. Now this time the coefficients match. 1/2 equals 1/2. And the constant, there's a 0 constant here. 0 on this side, 74 on that side. So there's no solution. You can even be a little bit more fancy if you want. You can do 2 times 4x plus 4 equals 8x minus 2. Now, after the distributive property, this 4x turns into 8x, this turns into 8. So all of these are examples where there is no solution. No solution because the coefficients match, but the constants do not. As long as you follow those rules, you are good. For number 9, write 2 equations that have one unique solution each. Well, you should go back to your page 61. One unique solution means the coefficients do not match. So as long as you have coefficients that do not match, you're okay. So you could do like 7x plus 7 equals 3x minus 2. The coefficients do not match. That's one unique solution. 3/4 x minus 1/2 equals 17/3 x plus 2/5. The coefficients do not match, so it is one unique solution. Coefficient is 3/4, coefficient 17/3, those are not the same, so it's one unique solution. Another example you can do pretty much anything. You can do x plus 1 equals 4x plus 1. Now there is only one unique solution that will work for this. Remember, the only rule for unique solutions is the coefficients do not match. The coefficients do not match. So remember, this coefficient is a 1. 1 and 4 do not match. It is one unique solution. Even if the constants match, if the coefficients do not match, it still works. Remember, for our rules, for one unique solution, the clue is only the coefficients. We don't care about the constants. We don't care about the constants. Last part, you were supposed to write infinite solutions. So for infinite solutions, our rule was the coefficients match and the constants match. So you need to basically come up with identical expressions for both sides. So you could do like 2x plus 7 equals 7 plus 2x. Same on both sides. You could do 11x minus 3 equals negative 3 plus 11x. Coefficients and constants match on both sides. You can even do something a little bit fancy like 3 times 5x plus 7 equals 21 plus 15x. Same thing on both sides. This is just before we use the distributive property. This is after we use the distributive property. They have infinite solutions. And that's what we're doing today. You are classifying your solutions. You are telling me infinite, one unique, or no solution based off of the clues. So when you're working on the problem set today, keep this page, page 61, next to you, because page 61 will tell you all the clues. And add page 61 to your notes for this lesson, because this is where the clues are. So use page 61 as part of your notes. Do not throw away page 61. It is part of your notes because it has the clues on it. So hopefully you have started to memorize the clues, and you can do it without and if you can do it without 61, that's awesome. But let's start looking at what you're going to be doing today for work. Now on page 64, you'll see the lesson summary, which is basically just a paragraph written about the rules we did on page 61. So we'll move on. Page 65 is your exit ticket, the last thing we do. So let me shuffle that to the back. Page 67 is your homework helper. Homework helper gives you 3 more sample problems, sample 1, 2, and 3, where they give you the equation, they show you their work, and they tell you what they were thinking. So if you want a little bit more help, read page 67, the homework helper. After you have a good handle on what we're doing and you understand it, your practice is the problem set on page 69. Work on page 69. There are 9 questions on page 69 where you are talking about no solution, unique solution, and infinite solutions. Follow the instructions. Like number 1, you're telling me what kind of solution this equation has. Number 2, what kind does this have? Number 3, what kind does this have? Number 4, it's asking you to write your own equation and then solve it for number 5. 6, write your own equations and solve one of them for number 7. 8, write your own equations and solve one of them for number 9 to prove you are right. So this is exactly like the work we did. Number 1, 2, and 3 are exactly like page 62. So 1, 2, and 3, we did the same thing on page 62. And the last ones, 4, 5, 6, 7, 8, 9, are like the work we did on page 63. And then, remember, this is the problem set. So my answers to the problem set are on the Google Classroom. So do page 69 yourself and then check your answers with mine. After you check your answers and you feel confident that you know what you're doing, then you are ready for page 65 and the exit ticket. The exit ticket has three equations on it. You have to tell me how many solutions and why. So tell me the answer and how you know. So exactly like we did on the work on page 62, I want you to simplify. I want to see that you simplified the equation. I want you to write down your evidence about the coefficients and the constants. And then I want you to tell me how many solutions. I need to see a simple equation. I need to see evidence. I need to see the answer. I need to see all three things: the equation, the evidence, and your answer. Do that for page 65, the exit ticket. And then when you're all done with that, take a picture of it and turn the picture in to the Google Classroom assignment so you get credit for learning this stuff. And after you turn it in, you get ready to work on lesson 8, which is coming up next time. See you then.